So, as you may know, today's 420, but since I don't do drugs, I have to find an alternative way to blaze it up, so I have made some spicy noodles. I don't know what I'm doing. Well, anyways, today I'm going to be explaining a bit about how spice works while eating these noodles. So disclaimer, I'm not some bio expert or anything. I have very limited knowledge on bio. So this is going to be some very basic knowledge on what happens when you eat spicy things. Alright, so let's start off with chilies. So chilies contain this compound called capsaicin, and basically capsaicin is a thing called a valenoid. So we have receptors that sit on our cell membranes, on our nerve cells, which are called TRPV1 receptors. The V stands for valenoid because they detect valenoids, just like capsaicin. So, we use them to detect things that can cause external stress, like things that are hot. So the thing is, capsaicin has a really, really long tail. It's hydrocarbon, which means that it's nonpolar. Nonpolar means that it can stick to our phospholipid bilayer on our cell membranes. Well, since it sticks there, it's going to trigger those receptors and continue to stay and trigger those receptors as it's stuck on the membrane where the receptors are. So, when the receptors detect the capsaicin, it pretty much sends a signal to the brain, and it's detecting some moderate sense of stress. It's not like some extreme form of distress where it's like, oh, all of your bodily function has to go to fighting this heat. No, it's just basically a moderate thing telling your brain, telling your body to release some sweat and to prepare, because some things are you have some external heat source that's in your mouth and it's causing some sort of pain. So this stuff is full of capsaicin because the taste is lingering in my mouth and it's triggering those TRPV1 receptors that are sitting on my membranes on all of my cells. So, what about wasabi? And like wasabi, when you taste wasabi, you feel a different kind of spice. Well, when you eat wasabi, you're breaking down, you break it down the compounds, and that releases something called alloisothiocyanate. So these alloisothiocyanate, these are smaller, and these things are extremely volatile, which means that they dissolve very quickly, they vaporize, and they sit in your mouth as a vapor. So when you breathe, you inhale it, and it goes into your nostrils really quickly. So what that means is that you feel a very quick burning sensation. They don't linger on your cell membranes and cause pain for a really long time, but you feel a really intense pain because it's as a vapor and you inhale it very quickly and it spreads out everywhere, and yeah, you feel a very intense pain because it pretty much spreads out everywhere, and you especially feel it in your nostrils because when you inhale, that's where these particles go. And these are actually detected by different particles. They're not detected by TRPV1 receptors, but rather TRPA1 receptors, which detect the alloisothiocyanate. Another thing to note is that when you buy wasabi from the stores, it generally isn't actually wasabi. It's some mixture of horseradish and some other spices. And it kind of feels the same as wasabi because they're part of the same family. They have, they both release these alloisothiocyanates when you break these particles down, when you break them down in your mouth. So then, yeah. So actual wasabi is something classified as Trima japonica, and it's, yeah, I know I anglicized the name. I really butchered it. That's alright. And it's a completely, a lot of people say it has a completely different taste than those store-bought, two-bought wasabis that you see everywhere. So, actual wasabi kind of tastes a lot sweeter. I can't hold on. Well, yeah, have fun. I have fun celebrating today. I really can't. I can't do anything more. I'm done.